Hi. Okay, so you should have watched two really cool videos on YouTube. One was really explaining ATP and energy systems, and the other was of a marathon runner that just ran out of ATP at the end of her race. And so, what this lecture is going to do is talk about and introduce anaerobic metabolism and these different energy systems that we use anaerobically. Aerobic metabolism is going to come a little bit later. So I know even though I showed a marathon runner that's aerobic metabolism, it all intertwines. So hopefully we can keep it straight. But to start out, the control of bioenergetics, how energy is used in cells, tissues, organisms, we have ATP. And again, I think the video that you just watched, kind of the animated one, did a really good job, hopefully, of explaining what ATP is. And we know that this is an immediate source of energy for muscular contraction. That's the high energy ATP. So before we get into some of the specifics of that, it's important to understand fuels for exercise. So I kind of gave the answer for this first fill in the blank, but that's okay. Carbohydrates are the body's preferred fuel source, particularly during exercise. Now, we don't directly use food. I mean, food is energy, but it gets converted to ATP, which is kind of our body's currency to actually utilize and produce and then utilize that energy. And then we know fats are concentrated fuel storage in the muscles and adipose tissue, main source of fuel at rest. And in prolonged submaximal exercise, your body will tap into those fat stores. And then protein, we're not going to talk a whole lot about. But this makes a small contribution during energy production. So, since we're talking mainly about energy production in this class, we're not going to talk about growth and repair, though proteins are so instrumental for growth and repair. We're breaking down our muscles, we're putting stress on our tendons. We really need protein for this growth and repair, especially on the molecular level. But for our fuels for exercise, we know that carbohydrates, fats, and proteins, these are nutrients consumed daily and they provide the necessary energy. And so we actually need energy at rest and we need energy at exercise. But during exercise, the main fuels that are used are fats and carbs. So proteins are not going to contribute a whole lot to the total energy used. That's more afterwards for the repair and the regeneration. During exercise, the main fuels are fats and carbohydrates. So carbohydrates will serve as the main energy fuel during intense physical activity. So this is also fuel for the central nervous system. We have monosaccharides, disaccharides, polysaccharides. We don't have time, and I'm not an expert on the nutrition level by any means. I love it. I'm fascinated by it. I think that nutrition and exercise physiology really go hand in hand, but that's not my area of expertise. So if you want to learn more about that, definitely take a nutrition class, but we're going to really focus on fuel for exercise and how that looks. So we know that whenever we consume carbs, it is converted to glucose. So glucose is used for energy. So glucose is used for energy. Excess glucose can be stored as glycogen in the muscle and liver, or as leftover excess glucose stored as fat. So excess glucose can be stored as glycogen oh boy. Let's get rid of that. Oh, good. In the liver and muscle. And then excess glucose will be stored as fat. And so this just gives a little description of liver glycogen used to maintain blood glucose, and then muscle glycogen will supply energy during muscular contraction. Now, if you remember back to our body composition lecture where we talked a little bit about obesity and overweight, we know that this leftover excess of glucose that's stored as fat, if it's not used for energy to fuel exercise, for the examples for this class, then it's stored as fat. And if you continue to eat excess glucose, it will continue to be stored as fat. And if you don't work off that fat, that's how we get into the overweight and obese state. So specifically talking about the anaerobic system, this system is used in all out efforts. So we're not talking about aerobic. That will be the next module. Well, maybe two more modules. We're talking about anaerobic. We're talking about short bursts of energy. And there's two anaerobic power systems available: the ATP-CP, the creatine phosphate system, or the glycolytic lactic acid system. So the anaerobic system is talking about two power systems. So the ATP-CP system is used for efforts lasting less than 10 seconds. So think about a 1 rep max. Think about a golf swing. Think about one pull-up. That is just efforts lasting less than 10 seconds. While anaerobic glycolysis powers efforts longer than 10 seconds. So lasting up to a few minutes. So this could even be, the 800 meters. I was a track runner, so I have to think of things in terms of the track. Can't convert that to like swimming. But anyway, an 800-meter run, typically you can do 3 minutes or less. So for our energy continuum here, again, thinking about these two anaerobic systems for weightlifting or the 100-meter sprint or the 200-meter swim, the aerobic, that's going to be greater than 2 minutes, which is not really what we're talking about. So we're really talking about things that are lasting, activities, sports that are lasting less than 2 minutes is using the anaerobic system. Okay, anaerobic energy system. So I showed this in the last module, and we're gonna circle back to this. So again, we have our phosphocreatine. So this is only gonna last, some say 10, some say 15. If you see a test question or anything like that, I'll make it very, very clear. So don't get too caught up in that. Just know that this is the first system that we tap into whenever we begin exercise. Your body doesn't know if you're going out for a sprint or a marathon. Well, I guess we could didn't have to jump to the marathon, a sprint or an 800-meter run or a 5K or a marathon. Initially, it's like, oh, we're running. How long are we going to run for? And then you kind of ease into that. My point is that you will tap into this phosphocreatine system first. And so this is 1 ATP per creatine phosphate, and your duration of energy is about 10 to 15 seconds. Then you can get into glycolysis or your lactic acid system. And this is our energy for about 30 to 60 seconds, maybe even up to about 120 seconds. Again, some books will sort of disagree where exactly that falls, but generally speaking, it's less than 2 minutes. And then oxidative phosphorylation, this is aerobic, which we're not talking about just yet, but this duration of energy can last hours. So we're talking, anywhere from a 5K to a marathon. So looking at our immediate energy system, again, this is less than 10 seconds, like a golf swing. Our short-term energy system, we're talking about less than 2 minutes. And then our long-term energy system is greater than 2 minutes to hours. So we'll review and revert back to this figure a couple more times, but just understanding phosphocreatine and glycolysis, these are your anaerobic systems. And then we have our third, which is not anaerobic, it's aerobic, meaning our long-term energy system lasting for hours. So even though we're really focusing on the anaerobic system, the aerobic system sneaks in there just to kind of help connect these dots and to help you understand both. Our first one, again, this is repetition, our ATP-CP system. We know that this is about 30 seconds to 3 minutes. Oh, I'm sorry. This is less than 10 seconds. And this recovery time is about 30 seconds to 3 minutes. For your quiz, what I'm calling a quiz, I'm going to have you come up with a sports performance, if you will, whether it's swimming or gymnastics or wrestling, and you're going to kind of devise a plan for this person and put in recovery periods to kind of train the anaerobic system. So revert back to this whenever I have you work on quiz 1. They're open book, open notes, so that's okay. I just don't want you to work with other people. So we know that this ATP-CP system is anaerobic. We know that the lactic glycolysis system is also anaerobic. We talk about ATP production. We talk about byproducts produced. We talked about how long this energy lasts for. So really kind of keep this graph in the back of your pocket, and we're going to talk about this. We haven't talked much about intensity in this class yet, and this will definitely be a theme and something that we continue to talk about. But when we think of high intensity exercise, we're thinking of all out max effort where you really do need a recovery. So let's say you're doing a 1 rep squat. So you do that 1 rep squat, you're going to need a few minutes to regain composure, to regain yourself, to even think about attempting that amount of weight again, versus if it was about 50% of your max, you could rep out more than one of those. So that's really what we're talking about here with the summary of the 3 energy systems. Okay, another graph. I love graphs. Now, before we get into really what this is saying, I would like to remind you again, let's look at our x-axis. We're talking about exercise duration. Okay, up here we were talking about duration. So this is kind of a visual discussing these energy systems. So for our exercise duration here on the x-axis, we have everywhere from 10 seconds upward of 5 minutes. Okay, this tracks. This is what we've been talking about. Then on the y-axis, we're talking about percent capacity. So usually with a percent, we're going up to 100%. We know down here is about 0%, and then obviously halfway between that would be 50%. So really pay attention to this graph because you'll see this again. So for our for our immediate energy system, so this first system we're talking about with anaerobic exercise, we know that it's an all-out effort, but you can't keep that all-out effort for very long. So less than 30 seconds. This really is just a visual of this table up here. So our immediate energy system drops off after about 30 seconds. Then we have our short-term energy system. So this energy is going to last a little bit longer than our immediate, and we're going to peak right at about 2 minutes, but at that 2 minutes, it's going to drop off. Okay, so our short-term glycolysis is really our less than 2 minutes, and that's what this line in this graph is showing us. 2 minutes. Drops off. And then finally, again, I know I say we're not going to talk about it and we keep talking about it, is this long-term energy system. So our aerobic, where that's really not going to kick in until 5 minutes. So you're not tapping into those long-term energy systems when you're only talking about 10, 20, 30 seconds, 2 minutes of work. That's going to kick in much later at the 5 minute and beyond mark. So really understand this graph and really make sure that you read questions and understand if we're talking about the immediate energy system, the short-term system, or the long-term system, which will be in our next unit, which is the aerobic energy system. So I like this. This is a little bit of a harder visual maybe to understand. So let me just show you what we're working with here. The concept's not difficult. So the contribution of anaerobic and aerobic use during sports. So we know that if we are at 100% anaerobic, we're not using any of our aerobic capacity. If we're at 30 seconds of anaerobic, we're tapping in a little bit to the aerobic capacity, but not that much. Whenever we get to that 3-minute mark, I know that an 800-meter at 3 minutes isn't going to break any world records. But for my example, bear with me. That's still hauling. That's still a 6-minute mile. That's still really good. So if you do an 800-meter run at 3 minutes, I will maintain that those mid-distance, I wouldn't call them sprints, but those middle distance events, especially in track, again, that's where my mind always goes. The 800-meter run is hard. Those 400-meter hurdles are hard because you are using 50% aerobic and 50% anaerobic. That's a really, really sweet spot physiologically to be working out at. And that's what makes, my opinion, the 800-meter a really, really difficult race because you're tapping in to both the aerobic and anaerobic. And then as we get to more into, say, the marathon, where you are using more or 100% aerobic versus our 0% anaerobic. So again, on the right-hand side here, it will give just some sports and some competitions and sort of where they fall in this continuum. So I'll give another plug here. Pay attention to this for quiz 1 as well. This will be something that you'll be able to come back and reference when I ask you some questions about that. Again, this is just a different way to look at this visual up here. We're talking about duration of movements of sports, what they're classified at, the energy that's supplied, and then a sporting example. So I'm not going to read through this, but just know that you have this here to come back and reference for your homeworks and your quiz. So to sort of conclude here, what factors affect how we train? So the next module, we're going to talk about training the anaerobic system. And so genetics, gender differences, delayed onset muscle soreness, differing levels of motivation, these are all things that limit our exercise ability and our training capacity. So, you know, I always make the joke that I'm an aerobic athlete. I'm never going to excel at the anaerobic type sports. That doesn't mean that I can't train and try to be better at those, but I know that my genetics kind of lends me to more of the aerobic sports, but you can train. And so you don't have to pigeonhole yourself into one specific thing, but definitely know that these are certain limitations that really affect how you train and exercise. So we talked today about fuels for exercise, mainly carbohydrates for that anaerobic power. We talked about the 2 anaerobic systems, our ATP-PC, and then our lactic acid glycolysis. And then we gave some examples of sports that are anaerobic, and those were in the end of this graph and then up here as well. So hopefully between the YouTube videos and this video, you have a better understanding and handle on aerobic energy and metabolism. And I will see you for the next module, which is training the anaerobic system. See you in a second.